So, how are things? All going fine with the new 12th standard content started?
Oh no, they didn't start it yet. They're going to start it from tomorrow.
Oh, okay. So you still have a break week,
No,
something
no,
like.
it's not a break. We went to school.
Hmm.
They taught like important, whatever is important, like from 11th or 12th.
Okay. It's not that only 11th is important. All of them are important on its own regard. Okay. Okay. So we can never give up on anything. Okay.
Yes.
Okay, fine. So we were solving some problems. So we can
Vectors
continue.
question. Yes.
Yeah. So everything. Mean don't leave it like this is important or that is important. So we should bring back everything what is required for our understanding. Is that okay?
Yes.
Okay. Also, let me take a. I will use a different whiteboard because the one we use it here is not getting recorded. I could not send you the PDF file. Okay,
Oh.
I will use it on the online whiteboard so that that is getting recorded. Okay. 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 So last week we saw one problem and solved it in two different ways. Do you remember that? Like
Yes.
the area of a
Yeah.
sector, right?
Yes. Yes.
So what I'm going to do, I'm going to share that problem. Okay, let me
And
share.
you've given me another problem on vectors.
Okay, did you solve that?
Yes, uncle. I think
Okay, so you got the answer, right?
I do not know the answer.
Yeah, but you should have a way to check the answer. It's
Yes.
not that somebody has to tell you that this is right or wrong. Do you get that?
Yes.
Okay. So do you see a whiteboard?
Yes, uncle.
Uh, okay, so what is the problem? Can you tell me that? The one we.
Yes, uncle. Yeah. A particle P moves in a horizontal plane.
Uh-huh.
At time t seconds, the position vector of P is r meters.
Okay. I remember that. Okay.
Yes.
Let me try to get that problem.
You
And
have
is
sent it to me, uncle. It's
yeah, in the WhatsApp I sent it,
yes,
right?
yes, 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 uncle.
If I'm not wrong, this should be the problem. Let's see.
Yeah.
This one, right?
Yes, yes.
Okay. So for the K, what value you got?
Uncle, I got 1/4.
For the problem number, the A part, you got the K
Yeah,
value as 1/4.
yeah.
You you
Zero
got
point.
you got an answer, right? So you should have
Yes.
a way to check back whether this is right
Okay.
or wrong. Do you get that? So
Yes, uncle.
the problem statement, whatever the answer we get, that should be part of the original data available, right? Information available. So otherwise,
Yes.
we have done something somewhere wrong. So a
Okay.
particle P moves in a horizontal plane. Okay. That means we need a two-dimensional XY coordinates to
Yes.
represent this problem. At time t seconds, the position vector of P is r meters relative to a fixed origin O, and r is given by whatever this, where k is a positive constant. When time t equal to 0, the speed of P is 16 meter per second square. So what you got is k is a 1/4. So when you plug this into our r, okay, so when you plug this into our r vector you calculated, which is a 20t minus 2t cube I plus, it will be a t 1/4
Yeah.
t square j. This is what you got. The r
Yes.
vector got changed. It is a time varying quantity. So we know that already at the time t equal to 0, the speed is going to be our speed is, we write it as modulus v vector, isn't it?
Yes. Yes.
Okay. So first of all, from this, let's calculate the v vector. V vector is going to be d r vector divided by dt. This is going to be 20 minus 60 squared I plus T over 2 J, isn't it?
Yes.
Okay. Now calculate the, we have been given an information V modulus at the time T equal to 2 is actually a 16 meter per second. So now do that. So in this, substitute the V at time T equal to 2 seconds. Is it okay?
Yes.
So that should become 20 minus 6 times 4 I plus J. So that will be 20 minus 24 I plus J. So this will be minus 4I plus J. Is that okay?
T is 2. Okay. Yes, sir. Yes, sir.
Any problem?
No.
Okay, so now we know the time varying velocity. So we want the modulus of that. Oh no, we know the velocity at that time. We want the modulus of that, right? When time
Yes,
is
sir.
equal to 2 seconds. That will be the modulus of minus 4I plus
Yeah.
J, which is equal to square root of minus 4 squared
Minus
plus 1 squared,
Yeah.
which will be square root of 16 plus 1. So which says square root of,
7.
yeah, this is not coming to the
Yeah.
square root of 17. So there is some, did I make any numerical mistake? I did not do that, right?
No.
Okay, so that means there is something to be done. You get that?
Okay. Yes, sir.
Need to check that. Let's go to the next page and do the problem and see what has happened. Okay, let me bring the question also again to this page. So this should be always a, like, we should respect the problem, the data, also our own calculation. You get that?
Yes, sir.
Okay, so to do that, we should have all possible ways. I know how to deal with anything and how to handle and check that I have done it correctly. So what we started was R vector, which is a time varying one, is 20t minus 2t cube I plus kt square j. So
Yes.
we go for V vector because we know the data given is modulus of V at a time t equal to 2. We know one answer as a 16 meter per second. So we are going to make use of that. We are going to do the same thing, but we are going to do in the forward way with the available data. So this is actually dr by dt, which is going to be 20 minus 6 t squared I plus 2k t.
Uncle 8 T square.
Why 8t square? T cube differentiation is 3t square, right? 3 into 2 is a 6. Where the 8 comes into picture?
Okay. Yeah. Yes, sir.
You are already substituting the 2 and finding something. I don't know where the t comes from.
No.
Yeah, you substitute the t as a 2.
Yes, uncle. Yes, uncle.
We are
Yeah.
not doing that. We are still finding this is where we can apply because when you substitute the 2, we will get the V of at a time t equal to 2. This is a particular velocity, which will be 20 minus 6 times 4 I plus 4k j. And we have been given that the modulus of this is given, right?
Yes, sir.
We are going to do the modulus of our at t equal to 2 seconds. To do that, we are going to find the square root of, okay, we can simplify this. This is 20 minus 24i plus 4kj. So this is going to be minus 4i plus 4kj. Is that right?
Yes, sir.
Okay, now we are going to say that this is a minus 4 whole squared plus 4k whole squared. So we are saying that minus 4 whole squared plus 4k whole squared is actually equal to 16 squared. Is that right?
Yes, sir.
So now this will be 16 plus 4k squared is actually equal to 16 squared. So now we could write this as a 16, factorize that. That will be 1 plus k squared is actually equal to 16 squared. No mistake here, right?
Yes.
So one of the 16 can be factorized. Then k squared is going to be 16 minus 1 is going to be a 15. So k is going to be square root of 15. I don't know where you got the 1 over 4.
Okay.
I think you have not done the differentiation properly.
Yeah. I got R is when I substitute, I got it as 40 minus 24.
Yeah, you cannot substitute in the or the time, because
Yeah,
when you
yeah.
substitute already, you are saying that I know the or only at that time, not the general
Yes, sir.
or, right? Because the
Yes.
given is a time varying quantity. You need to plugging into a number, you are looking at a particular case, particular situation, and that is not the complete dynamics. Do you get that?
Yes, sir.
Okay, never ever think like that. It is actually your thought process is not clear. You are saying that if I have a number, I plug in and I can work over that. That is not the right way. Do you get that?
Yes, sir.
Okay. So if you plug in the 15, it should work out. Okay, let me go to the previous page and see whether we could see that. So we plugged in the 1 over 4, right?
Yeah.
So this time around, let's plug in the 1 over 15. Is that okay? So we got everything is okay here. So the V
K is root 15.
yeah, root square root 15. Yeah, that is what we need to use. So the V vector is going to be our okay. So the R vector itself is going to be our 20t minus 2t cube I plus root 15 t square j, right?
Yes, sir.
Okay, now this is the differentiation of that. This will be 20 minus 6t squared I plus 2 root 15 tj. Now v vector of at the time t equal to 2. Now you can substitute the 2 because we get the complete v of t. So this will be 20 minus 6 times 4 I plus 4 times root 15j. Okay, so this will be minus 4i plus 4 root 15j. So now we have a job to do, which is going to be modulus of minus 4i plus 4 times root 15j. This is going to be square root of our 16 plus 16 into 15. Is it okay?
Yes, sir.
Yeah. So 16 can be factorized and 4 will come out square root of our 16. Is that okay? So this will be 4 times 4, which is going to be 16 meter per second. That is data given. Do you get that?
Yes, sir.
So everything, if we are, as we are, we will be careful in normal things, right? When we walk, we look at things. And then even if you are falling around, you need to find the support. What is available in that situation, you go around and try to stop yourself from tripping. Do you get that? Like that.
Sir.
We should have all possible, because the main distraction we have in doing some kind of analysis and analytical subject modeling and calculation, the thought process about what we already know about something like that will pop up in our mind, and that will force us to plug that thing in. Do you get that?
Yes, sir.
Like the numbers, we have been forced to play with the numbers for so many years, and we have been not taught properly also. People, that is, the main reason the people who are teaching, they themselves don't have the idea. They don't have the understanding correctly. You get that?
Yes.
So that thing has made everybody like, okay, if you do it, the things will happen correctly. No, it's not about doing. It's about, first of all, what is available, what I am doing. We should have a rationale behind that. So every step you make, you need to first of all question why you are making that step. Because when you first ask the question, that will help you. Okay, I need this, as this is available. If I want this, then I can take this step, will give me that one. Do you get that?
Yes.
And also you should know, if I go back, I should get back the step, the original one. So we should never get away from the original problem. So when we were solving a problem like this, or any problem, even you know that, I mean, there is a position vector is given, which is a displacement vector, and the data about the speed is given, which is a magnitude or the modulus of our velocity vector. There is a relationship between the velocity, I mean, the speed is given. First of all, we think that, okay, R is known for all the time. Speed is known only for a particular time. Do you see how the connection are coming?
Yes, sir.
That has to trigger, okay, if I know R for all the time, if I know speed for only a particular time, what is the connection between them? Okay, speed is nothing but the magnitude of the velocity. Velocity is defined as the rate of change of displacement with respect to time. Okay, take the general function of the R with respect to time, which is already provided in terms of time. Differentiate that with respect to time, will yield the V for all the time. Then
Yes.
you are ready to plug in. Now you are ready to plug in the T, because the S is given to us, the magnitude of the V. Let's say in the same problem, instead of the speed, let's say if they have given you the acceleration, what you do? We need to differentiate the V again for the one more time. Do you see
Yes.
that?
Yes.
So there is a reason for every step we make. Actually, the step is deduced by us, derived by us. Do you get that?
Yes, sir.
It's not because we know. I mean, in this, I mean, we can do a lot of things. Why we do only a particular thing? Like why we think about doing a differentiation of the R? That is because from the known quantity, what quantity we want to calculate, that led us there. Do you get that?
Yes, sir.
So that should be the always. And every step you make, you should have a way to go back. Okay.
Okay.
Okay. So definitely mean the acceleration of P at the instant when it is moving parallel to J. Okay. This is totally a different case. You tried that also?
Yes, uncle, but then I did that also wrong because I substituted K as 0.25.
Okay. You did that and started doing that. Okay.
Yeah.
Okay, that. So let's pull the problem again here and try to look into that. Yeah, and I mean, I was telling you that the known things about substituting the values and playing around with all those things, they may pop up in our mind. Okay, that is the main
Yes.
distraction. Try to avoid that. How to avoid that? Keep every statement you are reading, populate the as if you are the object, or you are seeing things happening in front of you or something like that. Draw some graphical equivalent or diagram or something like that, and think about that. Okay, if this is available, then I can do some Pythagoras theorem here or trigonometry here. All those things will not distract you from putting your own assumption into the problem. Do you get that?
Yes, sir.
So two important things. One is our own assumption plugging into the problem will be a bigger trouble. Second thing is what is given to us, we don't care all of them and leave it some of them untouched or not given proper consideration. That will lead to error also. Do you get that?
Yes, sir.
Okay. So now we got here R is solved, K is solved as a root 15. And quickly I will ask you, what could be the unit for this K? It's got any unit?
No.
Possible?
No.
So you don't look into the data and the problem situation and everything and try to look, okay, there is or not. You are saying that immediately, but why that came into picture? Like K cannot have a unit. Who said that? Why it made you to think like that? Where is the K? R is the vector we know. This is given to us. That is 2t, 20t minus 2t cube. I is a unit vector plus k t square. So this is also part of the understanding. When an equation is given, we need to have a look at it. See the beauty. This side is here. Okay, even though it is a vector quantity, this unit is a meter. We get that?
Yes.
And that is also already given to us. We have told that it is here or meters. So completely the right hand side should also be meter, but it got two quantities added together. So addition or subtraction both are same. Each one of them should be a meter. Do you get that? Then only we can add two quantities. Otherwise, we are doing completely wrong. It is a vector addition, doesn't matter, but one vector along the I direction and another vector along the J direction. But if you take only the 20t minus 2t cube, definitely I vector is just a unit vector. On its own, it doesn't have any quantity units is not available for the I. Do you get that?
Yes.
Because that itself is a unit. I mean, for the direction unit. Okay.
Yeah.
So this complete. So individually, these two quantity, this has to be a meter, and this has to be a meter. Then only we can subtract them. Do you get that?
Yes, sir.
But the t alone got a unit. That is a second. But only what is the 20 is doing? A multiplication with the t. So the 20 itself, you need a unit like a meter per second. Then only this second and this second will cancel and lead you a meter unit here. Do you get that?
Yes, sir.
So it's not that numbers don't have a unit, because every quantity will finally be a number, right?
Yes, sir.
Okay, same thing. If you want the 2t cube to be a meter, this t cubed will have a second cubed. You get that?
Yeah.
So the S unit should be, 2 unit should be?
Meter per second cube.
Meter per second cube, which is called a jerk or a jolt. Do you get that? Because meter per second square is the acceleration. If the acceleration is also time varying, then we go for the cubic one, which is called a jolt or a jerk. Okay. Okay, so then only this meter will be available. Is that okay?
Yes, sir.
Same thing. Now tell me what is the unit for the K?
Okay, so T we know that it is second square.
Yeah, T square is second square.
Yeah,
so
T square is second square. So and we know the entire thing should be meter. So it'll be meter per second square.
It's an acceleration actually. So so you see why I questioned that, because when we calculate the acceleration, maybe it may appear. So that may help us to also check the answer.
Okay.
Do you get that?
Yes.
Okay, so now part B is saying the acceleration of P at the instant when it is moving parallel to J. So what thought process led you to do something? First of all, can you feel it? When the particle is moving parallel to J, what kind of information we can deduce from that?
Yes, parallel to J means parallel to J means I is constant.
What I is constant? Because I is just a component of a vector. Do you get that?
Okay.
So which vector I is a constant? Do you see my question?
Position vector.
Why the position vector and why you think like that? But it is moving, right?
Yeah.
Moving parallel. So there are two things. Moving means R is changing, first of all.
Okay.
And the parallel means parallel to J is another thing. So combine them. Think over. So moving parallel to J means it is going something like that. Do you get that?
Yeah. Yes, sir.
Vertically up.
Yes.
So already the R is a time varying one, right?
Yes.
So we cannot say a particular position can answer this moving parallel to J. Do you understand what I mean?
Yes, sir. Yes, sir.
You need at least 2 points. You may have it at this point and another point. So let's say you know the R here and you may know a R plus dr.
Okay.
So a small change happened in the R, but the change has to be parallel to the J means what you need to do, how to find what can get you this. First of all, how to find the change happened in the R, because the change is happening because of the change in the time, right? Because
Yes.
at this point, the R is at a time T. Do you get that?
Yeah, yes, sir.
At T. And this is at T plus dt.
Plus dt. Okay.
So you know that, I mean, R dynamics completely known. R is given to us as 20t
Yes.
minus 2t cube I plus root 15 t squared j. Let it be. But now, how to even think about, there is a change happening with the, so definitely you cannot use R. So what is the change happening with the R with respect to time? What that quantity is defined as? What you call that?
Speed.
The velocity, not the speed. Okay,
Yes, okay,
use the word, because the V we have already defined. The V vector is nothing but dr by dt.
Yes, sir.
So we are saying that the dr by dt at a particular time is going to be going parallel with the J. Do you get that?
Yes, sir.
So first of all, get this. This we already got it, right? So we have to differentiate that. So we if you differentiate that, this will be a 20 minus 60 I plus 2 root 15 t j. We are saying that this is the change happened with the displacement with respect to time.
Yes.
But this is having both the time in here also, in here also. That means if you plug in different time value, this is going to change. Do you get that?
Yes, sir.
But we are saying that this is moving parallel to J. That means what? When something is parallel to J, in this, the J I component is there, J component is there.
Yes.
When this is going to be parallel to J means what?
Yeah, so the value of I will be a constant.
This is not changing at all. Okay. So that means we are saying that 20 minus 60 is actually equal to 0.
Okay. Yes.
Does it make sense for you?
Yes, sir.
So this will lead to our t is actually 20 over 6. It is going to be 10 over 3 seconds. Is that okay?
Yes, sir.
Okay, any questions?
No questions.
Do you see how our thought process should help us to go further in doing things? Okay. Okay, I can give you similar problem, but before that, I was doing something, and this problem, you remember the one we solved for the sector? And
yes.
In the second method, we went to, like, when you have a circle, we say that in a diameter, if you draw a triangle, this will be 90 degree. Right?
Yes, semicircle, yeah.
Why? Have you ever thought about proving this? It's an interesting proof, right?
Yeah.
Very important. Also, we do the other thing also. Let's say if you have a circle, if you have a radius, and if you draw a tangent to that, the tangent will meet at 90 degree also. So ever thought about doing this?
So we can, we can draw a line.
This is the first problem. This is the second problem. First, try to, draw
a line parallel to the diameter on where the angle is.
So you want a tangent there?
No, no, no. No,
Tangent at the point.
no, no. 1 second. I'll just try 1 second.
Yeah. Think along the line, we are in a circle. What is already available to us? What we
The
are
radius
seeing?
is equal. The radii are equal.
Okay. So you
Yeah.
are saying that there is an origin and this is a R and this is also a R, you are saying. Okay. With that, what can help us?
Yeah, so we can. So we know. Okay, so we can draw like the point where 90 is, we can name that point as A.
Hmm.
We can join OA.
Okay, you are drawing a radius from A, right?
Yeah. Okay, yes.
Good. Okay. Okay. Then the problem is solved actually. So then what you see?
Now we can say
Call
that.
as B, B, C, for example.
Yes, uncle. So now we know that these two triangles are congruent.
Why you go for congruent triangle? This also R, right? They are all isosceles triangle,
Okay.
isosceles
Okay.
triangle, right?
Yes. Yes, uncle.
So this A can be split into a angle A1 and A2.
Yes.
You see that?
Yes. Yes.
So that means this angle should be a,
What's
if this is R and this is also R, then this angle is A1 means this angle is
that will also be A1. Yes.
A1 and this
Okay.
angle should be
That should be A2.
A2. So we know
And this will be 90.
not 90. Who said that that can be 90? I put the point there. I put a point here, then you say that is 90.
Okay.
By the look of it, don't get carried away. Do you see that?
Okay. Yes.
You are doing that too often.
Okay.
You are settling very quickly. So this is simply a, okay, do you see that ABC triangle is still a triangle, right?
Yes, yes, uncle.
BAC. So in the BAC, you have three angles that is starting with the A1 plus the A plus the A2 must be equal to our 180.
180.
For
yes.
sure.
Yes.
But this can be split into A1 plus A can be split into A1 plus
A1 plus A2.
yeah. Or okay, we want the A as such, but rearrange this. This A1 plus A2 is also A. A plus A is 180.
Yeah, yes, uncle. Yes.
Okay, so 2A is okay 180.
180. Yes.
2A is 180. So that gives you A is 90.
Yes.
Okay. So there
Yes.
are two things here again. Like first thing is the first step. What need to be done to take us to the solution or what we want to achieve? That may be sometime difficult, but we need to feed it our using our thought process. What is available? What is the situation? What extra thing if I add with that? But whatever the extra you are adding should not impose any assumption. Do you get that? Our own
Yes.
fantasy can be anything because we want the problem to be solved. And that is what I was saying. Our mind will be always looking for, go for this is same, this is equal, this is 90 degree, this is 0. Because those are all the things we have been told again and again and again. But they are all our thought process.
Yes.
If they are not actually fitting with, or we need to find a rationale behind, that is what is called evidence, right? So we do critical analysis. When you do the critical analysis, our knowledge may help us to add more thing to the available thing during the analysis. But always we need to investigate the extra thing what we are thinking to bring out the correct evidence from the situation or the problem statement to support that. Do you see that?
Yes, sir.
If we are not doing that, then we are not respecting the problem and we are also not respecting our thought process. We should never do that. Is that okay?
Yes, sir.
Okay. I will leave this problem as your second problem for next week. Is that okay?
Okay, fine.
Let us bring a similar problem because we just solved that vector problem. Let me bring another problem to see how your thought process and then always remember that, because in the beginning it may be a bit difficult to always think about, have I taken consideration of everything and I am not deviating from the information or the situation, or I'm not making any unnecessary assumption which is not fitting into the problem, right?
Yes, sir.
Okay, so now can you see the problem in full?
Yes, sir. Yeah.
Okay, in any case, I will also put it in your WhatsApp so
Yeah.
that we are not completing everything today. That can also wait for next week. Okay, so let's read the problem and use every terminology, every information, data, units, everything, and be there. Think around, in and around those things, so that your
Yes.
brain is not immediately jumping into some conclusion. Do you get that?
Okay. Yes, sir.
Even if you
So,
think like a conclusion, you should try to find a evidence to support that. As long as
Okay.
that is fitting, you are okay.
okay. Yes, sir. So unit vectors east and north. Okay.
Yeah, in the previous that problem, we have not completely solved the problem. I stopped it. Sorry about that. I don't know why I did that. We solved the time, right?
Yes, sir. Oh,
But
we're
the
supposed to
question was
find acceleration.
acceleration.
Okay.
Okay, I did not do it. Suddenly, when I come read this
Yeah.
problem, that popped up in my mind. So what we should have done, we
We
got
got 10 by 3.
yeah, that is okay. Let it wait. But we have the v vector.
You have to differentiate it again to get
Ah, this has to be differentiated. So we want the a vector, which is going to be dv by dt, which is nothing but our minus 6i plus what I did. This is a t square, right?
t square. Yeah.
I made a
Okay.
mistake here. You also did not correct me
Yeah.
that. So this should be a square root, isn't it? Is it not?
Mm.
Square root of 10 over 3, isn't it?
Yes. Yes, sir.
Okay, so this is actually is the eraser. I don't find an eraser here. Draw shape, line, text. They don't have an eraser. They don't have an eraser.
Well, I think the third one in that is eraser. The next.
No, this is a line. This is
No, no,
line.
no. No, when you click on the pen,
Uh-huh. Ah,
the
yeah, okay. Okay. So, okay, let me erase this and then try to do this differentiation again. Because I made a mistake. Found that. Okay. So we need to differentiate that thing. That will be minus 12t
yes.
I. Yeah, plus
Plus 2 root 15.
2 root 15. Okay, so this is called, so this is where I was talking about. You see that this 2 number came from the differentiation too. Do you get that?
Okay.
So that won't have any unit at all, because that is a mere dimensionless quantity.
Yeah,
So the
okay.
root 15 still have the meter per second
Meter per
square.
second.
So
Okay.
that fall in place. Do you see that?
Yes, sir.
Because this is our a vector.
Yeah.
So that makes but still this is a linearly time varying acceleration. That means this whole quantity should be meter per second square. We have a t here. So this 12 should be meter per second power cube. Do you get that? Second power 3.
Yes. Yes.
Then only one of the second will cancel, and then we will. So there is a deceleration going on because it is a negative value. Okay.
Okay.
So in there, we can use the a of at a time t equal to root 3. There is a j here. Root 10 by 3. Is that okay?
Yes.
So that will be minus 12 and square root of 10 over 3 I plus 2 root 15 J, unit is meter per second square. Is that okay? So this will be
Yes.
the, so this will be an, because they are not, so this has to be, and also this only an acceleration, you get that?
Yeah.
But we all started when it is moving parallel to J. So we got the time. How to check? First of all, this time itself is a correct value.
Uh, it's substitute it in R, then we'll
R still, R will give you some value that will give you only your position, a particular position. You get that? It is
Yes.
moving parallel means substitute into the V to check whether it is cancelling the, that thought process still not clicking your mind. You get that? So if you plug in the root 10 by 3,
Oh, so I will be 0.
for the V. You
Yeah,
see?
it will be okay. Okay.
Okay, let me take it to the a new page. I'm trying to, okay, let's bring the first problem itself again to get more clarity. Okay. I don't want that. I don't want this. Let's go to the previous page itself. This page, let's cancel this, remove this. And I bring the first problem here itself so that let's check that. Because that is always we need to do. So I was very, that would have actually corrected our mistake there itself. You see, after we made the mistake, actually we are thinking about it. So we have the R is 20t minus 2t cube I plus root 15.
20t.
20t root 15 t square j. Is that okay?
It's 20t minus 2t cubed.
Okay.
Yeah.
So B is going to be 20 minus 6t square I plus 2 root 15 t pj. So we got the parallel time was root 10 over
10 by
3 seconds. So V at root time t equal to root 10 over 3 second is going to be our 20 minus 6 into 10 over 3. Obviously, this is actually going to be 0. You get that?
Yes.
So I plus 2 root 15 and multiplied by 10 over 3 j.
Yeah, that will be 0.
Yes, this will be 0. So this will go to 2 root, this will be a 5, 50. That will be 2 multiplied by 25. J is going to be 5 can come out. That will be 10 root 2 I. So this is the, so this is the velocity, which is actually, we have a velocity which is pushing only along the J. Do you get that?
Yes.
So if you want, you can calculate the R vector at the time t equal to root 3 by, root 10 by 3 seconds. That will yield our 20 root 10 by 3 minus 2, 10 over 3 will come out. Root 10 over 3 will be another one. You're okay with this?
Yes, sir.
How much I plus root 15 multiplied by 10 over 3, so much j. Is that okay?
Yes.
Yeah, so this will be, yeah, this will be 20 root 10 over root 10 over 3 minus 20 over 3 root 10 over 3 I plus root 15 multiplied by, yeah, multiplied by 10 over 3. Yeah. So we can factorize the root 10 over 3 outside. So this whole thing is going to become
20.
20 is a 60 over 3, 40 over 3. Is that okay?
Yes, yes, sir.
So you see this is the position at which it will be moving parallel. Do you get that?
Okay, yes, sir.
Position is somewhere. It need not to be, because when you put this equal to 0, we are saying that the position has to be on the vertical axis.
Yes, sir.
That need not to be for the moving parallel to J. Do you get that?
Yes, sir.
What it means, this gives you a value which looks like 10 over 3 root 15J. It is somewhere in the first quadrant. Do you see that? Somewhere in the first quadrant, this position vector is. So the object is, particle is here. Do you get that? This is our R. Do you catch that?
Yes, sir.
And at that point, at that time, that is moving. So this is the tangent at that point. So it may be a curve. It may be moving here and then it is parallel. You see that?
Yes,
So
sir.
tangent. So we have to find the tangent should be parallel to the J. So the tangent at the point can be calculated. The tangent will be calculated by dr by dt.
Yes, sir.
And the dr by dt has to be 0, but the tangent only for this part. Okay, for the J, it could be different. Do you get that? That's
Yes,
why
sir.
we equate this to 0. So the first derivative equal to 0 will give us the moving parallel to J. You're okay with this?
Yes, sir.
Okay. Okay, let's bring the next problem and see how much we can do for today. Okay. Okay, in this question, I and J are unit vectors, east and north respectively. Okay. Hello?
Yes, sir.
Yeah, read it loud, please.
Yeah, okay. So in this question, I and J are unit vectors of east and north respectively. Okay. At a particle P is moving in a plane. Okay. At time t seconds, position vector of P r meters relative to a fixed origin O is given by r is equal to 5 e to the power minus
3ti
3ti plus 2j.
equal to read. Okay, let me expand that.
Yeah.
Okay.
Yes, sir. Now it's there.
Okay, so everything when we go every first line itself, so you can see that they are giving a plane which looks like, we know that there is a I vector in this direction and J vector in this direction. According to the problem, this is our east. Do you get that?
Yes, sir.
But this is our north. So that fits with the very standard one. Okay, up is north and right is east. Fine. Now a particle P is moving in a plane. This is our plane, right?
Yes, sir.
At the time t seconds, the position vector of P in terms of r meters related to a fixed origin, that is our O here. Okay.
Yes.
Is given by r equals 5 e power minus 3ti plus 2j for all the time from 0 to higher values, positive values. Look
Uncle,
at
just 1 minute.
Yeah.
1 minute. Sorry, 1 minute.
Yeah.
Yes, sir.
Yeah. So look at the R vector and try to feel that and tell me what you understand from the given quantity. In the previous problem, I told you R vector is the I component is a linear and also there was a cubic term, right? And then the J component was a square. Do you remember that? Hello? Hello?
Yes, uncle.
Yeah, okay.
Yeah.
Okay, so I was typing something for you. Okay, so look at here. By the look of the first problem, R vector, we have a I component and a J component, right?
Yes, uncle.
So we know the function, the time varying function will tell us in what way it is moving. So in this case, there is a linear part for the for the I, and also there is a cubic.
Yes, sir.
In case of the J, it is a parabolic. Do you get that? Quadratic.
Yes, sir. Yes, yeah.
Similar to that, because here both of them are time varying. Do you get that? I also
Yes, sir.
time varying. So you can imagine it is going to move on the plane. Similar to that, the current problem, can you look at the R and just tell me what that is?
It's e to the power minus 3t. And can't be cubic.
You cannot force something. It is already exponential. You cannot. Exponential has all the terms, right?
Yes.
Have you studied this or not? E power. Okay, if you want, I can.
No, uncle.
E power you studied, right?
No, uncle. We just had a log e power x is e power. That's all. We didn't teach us anything else regarding e.
You know what is? You don't even know what is E. Okay, you know what is? You study so much about log, right?
Yes, uncle.
And a log, if you write log base E,
Yeah.
what you thought that base E is? It cannot be a variable, right?
Yes, uncle. It's constant.
Yeah, it is actually 2.732 and it goes on. You know
Okay.
how we calculated this? This is actually a natural number. This is a natural constant actually. Natural constant is very important in
Okay.
everything. Is not mean all the modern technology and everything all based on this E.
Okay.
And what this can help us in all the mathematical modeling and everything. Actually, e power x can be written as 1 plus x over 1 factorial plus x square by 2 factorial plus x cubed by 3 factorial, and it keeps going
Okay.
plus up to infinity. But as the denominator are all factorial of bigger and bigger numbers, all the contribution for the higher power, they go down very quickly. So already if you put, when you substitute this as e power 1, that is x equal to 1, we are talking about 1 plus 1 over 1 factorial plus 1 over 2 factorial. Do you see that?
Okay. Yes, sir.
So all of them will simplify to that value. That is how we got that. You understand that value?
Yes,
That
sir.
0.732 came from there. So it is a 1 cubed by 3 factorial. So plus, so already if this is in, these two terms itself will already giving a 2.
Yes.
All the other up to infinity is contributing only a 0.732. Can you believe?
Okay.
Because quickly they are all divided by, even we can say that this is half. Do you get that?
Yes, sir.
So these three terms put together, already it is a 2.5.
Okay. Yeah.
And this is a 0.3, isn't it?
Yes.
Point
1 by will be
3 factor 1 over 6. That will be
6. Yeah.
6 will be 1333, right? 1 over 6 is
It's 1 6. I think.
1666, 1666, right?
Yeah. Yeah.
Yeah. So that itself, if you include that also, already we got it as a 2.66 already.
Yeah.
So
Yes.
all these things are all contributing very, 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 very low value.
Yeah.
So anyhow, I mean the E is very important. Okay. Also,
Okay.
I mean, for the rotation, all those stuff, the E power I theta is very important. So all these things are fixed to that. So simply mean you need to look at a function by, can I plug in some numbers that can gives some idea? You know straight line. So T is no problem. But here we are talking about a constant value plus a linear, a quadratic, a cubic. It will go up to infinity power. Do you get that? So you cannot
Yes.
fix it with one power for this. But what you could do, if you substitute some time value, plug in time t equal to 0, what will happen? It is a e power 0.
0. Yeah.
It become a 1. So
Yes.
R of, that is how we need to understand. R at time t equal to 0 will look like 5i plus 2j.
Okay. Yes, uncle.
So this position is very fixed. Do you get that?
Yes.
I amount here and here 2 amount here. So this is the vector we are talking about. The position vector is this position vector.
Okay.
And this is our 5i plus 2j. Then
Yes.
the time increase, because it is going to be all positive values. Now, which direction it is moving and what you can think about it. Can you look at the R vector, complete R vector, and tell me in what direction it is moving and in what way it is moving?
It is moving in.
When the time is
North
increasing,
east.
what is changing in the R?
When time is increasing. Okay, 1 second.
Okay, you think about it and we can discuss
Okay.
next week then. Okay.
Okay. Okay. Uncle.
Okay.
Yes.
Okay then.
Okay.
Okay. Bye.
Thank
Take
you.
care. Yeah.
Thank you.